Good morning to all. Today we discuss about computer and communication networks. So the first unit network model. In this unit we are discuss about communication, what is the need of communication and what are the different type of components and then representation of data flow, networks and physical structure of the network types. We have on a several number of network types: PAN, LAN, MAN, WAN, switching and internet protocol layers, scenarios and then principal logical connection between the network, what is meant by TCP and UDP protocol should, and layer architecture and layer NTCP IP should, and description of layers, and then encapsulation and decapsulation, addressing and multiplexing and demultiplexing, and main topic is OSI model and OSI model versus TCP IP layer. Overview of data communication: to exchange the data between source to destination or source to receiver. So transmission media such as a wire, cable, transmission media such as wireless media. Transmission media data made the data to transmit the data one location to another location. So, different type of components in communication media. We have on a five components: sender, receiver, transmission, protocol, and message. Sender, nothing but is computer is generate and sending the message. Receiver, computer that receive the message to the sender. Transmission medium, we have on a two type of medium we are using in network communication: wired and wireless media. Wired media is connected to the entire system with a wired, and wireless media we are using Wi-Fi connections. The protocol is nothing but set of rules, so transmitting the data between sender and receiver. So message is information or data. So this is a simple architecture for data communication sender to receiver. So you can type the text, "Hi, how are you?" So data to sender to transmit the data between the machine to wire media to convert it to a binary digital format, the ones and zeros. So ones and zeros cannot transmit the data from the cable. You can convert to the analog signals. So say receiver side receive the analog signal into digital form, then you can convert into message to the receiver. So these are the terms of protocol function we are using the data communication. The first protocol is the data sequencing and data routing, data formatting, flow control, error control, data security, and lock information. These are the some of the characteristics of communication: delivery, accuracy, timelines, and jitter. Networks we have on several number of devices we are using communication purpose. The collection of computer and server mainframe and network device. So what is the main aspects for the networking? You sharing the data and information between the one location to another location. This some of the network devices. First is computer, firewall, bridges, repeaters, switch, hub, modem, and router. So network types. The network basically is classified as six types. We have called it as a topology. Topology is nothing but to frame a network for other computers. The first of all is used bus topology. So star topology, ring topology, mesh topology, and tree topology, and hybrid topology. So bus topology is multiple devices are connected to one by one in centralized cable. So star topology is number of devices connect to point link between a centralized hub or switch. The ring topology is one node connected to the another node and connected to the another node. So it is a format. The mesh topology links between each device in the network. Hybrid topology is combination of two or more topologies. So in this simple architecture of bus topology, The bus topology we have connected to the centralized cable. Each way end we have a terminal. So what is the use of terminal? To extend the connection, we are using a terminal to connect it to the more number of devices in a single cable. So what is the main advantage in the cable cost will be reduced, easy to transmit the data from the one node to another node. So what is the drawback for the bus topology is in case of any cable is crashed, cannot execute the data from the neighbor nodes. This is a star topology. Star topology is connected to the centralized hub or switch. So n number of system is connected to the switch. So each and every system is connected to the centralized node. So we have to receive the message to the source to destination, easy to transmit with the data from one node to another node. So drawback for the star topology is more number of cable will be used in the star topology. In case of hub will be failure means total network will be failure. A ring topology. The ring topology is connected to one node to another node. So another node to another node. It is sequential process between last node connected to the first node. So the cable cost will be reduced. In case of any cable is break between the node, so cannot execute the further transaction. The mesh topology is nothing but each node connected to the every node. So in case of any data transmission is very easy to transmit any node. So more number of hardware component and cable will be used in the mesh topology. This is a drawback for the mesh topology. So tree topology is in a hierarchical form. The root node then connected to the two node and two node connected to a multiple node. In case of root node will be failure, cannot execute the further transaction. So hybrid topology is nothing but two or more number of topology interconnected between the one network. So here we are using bus topology, ring topology, and star topology. These are three topology is interconnected between the particular node. This is called a hybrid topology. So network building blocks. Here we are using three components of network building blocks. So client computer, server computer, network interface. So client computer is computer that you and the user to use to access the resources. The server computer, computer that provide share the resources. Network interface, interface sometimes is called a network port. This is a simple architecture for network building blocks. Here we using sender and receiver. Sender means client side and receiver means it is receiver is on the server side. You have an interconnection between the two. So you can request the client, you can request the response from the server to provide the response to the clients. So we are using some type of network device, repeaters is operate the physical layer, is a lowermost layer. Hub is basically is multiple repeaters, but there's multiple repeater. We have now two types of hubs, active hub and passive hub. Bridges operate the only second layer is data link layer. So we have two types of bridges, transparent bridges and source routing bridges. Switch is multiple port switch. You can connect to the n number of nodes. We are using start topology. We are using mostly switch. Repeater is a repeater device like switch that routes the data packets. So gateway is mere passing to connect the two networks. So these are the simple the network devices, switches, hub, repeaters, bridge, gateway, and repeaters and routers. The types of communication networks. Generally, we have one of four type of networks: local area network, metropolitan network, wide area network, and wireless network. So local another than the type of communication network is the personal area network, campus area network, storage area network, and system area networks. Local area network. Yeah, node or computers connect to peer to peer. So one node to connect it to another node. We are using some different type of topology is connected to the and networks. So simple building or campus. We are using a local area network. Your organization, full organization or education institution. They are mostly using a local area network. So within a campus, it will connect to the n number of nodes. It is a main advantage is a flexible speed, reliability, and as well as security. The two characteristics, so we are using any type of topologies using protocols and media. So this is a simple architecture of local area network. So client computer or laptops or any other computer interconnected between the switch, and switch connected to the server. So any client requests the services from the data, you go for a switch, then go for a server to provide the services to the all clients. Metropolitan area network. So it is a larger than LAN area network. So connected to the city to city. If you have any different organization in one city to another city, he can use the metropolitan network to interconnect between the two cities to transmitting the data. The transmitting rate will be, for the metropolitan network 32, 34 to 150 Mbps. This is a metropolitan area network architecture. The different networks with different organization in the different location. So interconnected to the metropolitan, you can share the information between the all nodes. So and next one is wireless wide area network. The long distance between the datas to connect worldwide. In accessing more number of users, the network will be go down. So low speed and most expensive and cover large area. This is a simple architecture to the wide area network. So we have on a several LAN network or WAN network are interconnected to the WAN to data transmit between the wide area networks. The social networks are we have one of Facebook, Twitter, Yahoo, and Google. Overview of Internet. So worldwide global systems is interconnected to networks. The Internet used to stand the Internet protocol. Each computer network is identified a unique IP address. IP address is a unique set of the such of IP address 110.22.33.114. The special computer is a DNS. A DNS is provide the IP address to provide the uh, services to the user. So, what is the main advantage of internet in online banking, online games, songs, videos, shopping, bill payment, data sharing, and emails? Disadvantages swapping component on unwanted emails in blocks, various virus will attack the systems. So protocol layer, the layer or a network that provide many services need my protocol. Some of the services are independent. DOT is a four-layer model. So for four-layer is a network access layer, internet layer, host to host layer, and process layer. The protocol layers, the OSI submodel, we have on several layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layers. So OSI model, the layer is OSI architecture, application, presentation, session, transport, network, and data link and physical layer. It is refers a model of protocol layer is function to the into in seven layers. One or more protocols implement to the function each layers. So OSI model, so its reference model is a protocol graph partition network functionality into several layers. One or more protocol implement the functionality assigned to each layers. The OSI model layers. So OSI we have several layers. The layers are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. This is the overview of an OSI architecture. The starting layer in sender side, application layer, presentation layer, session, transport, network layer, data link layer, and physical layer. The receiving end, the physical layer, data link layer, network, transport, session, and presentation layer. It is refers to the model of protocol graphs, the participation of network functionality with 7 layers. One or more protocols implements the function to assign each layers. The OSI or ISO 7 layer model, so it is referred the model of graphical protocol graphs present in the network functionality for the 7 layers. One or more protocol implement the functionality assigned each and every layers. The physical layer, which is the lowermost layer, transmit bit stream from the communication channel to sender to receiver. The physical characteristics of interface and media represent only a bit stream, data or transmission rate to synchronize the bit stream from the source to destination, line configuration. We are mostly using several number of physical topologies and transmission media. This is a simple architecture of physical layer. The data link layer, the lowermost, uppermost layer is received that a frame into physical layer. Physical layer is converted to binary streams, so ones and zeros. The ones and zeros to transmit the transmission media. We are using a two type of media is wired and wireless media. Here we are using a wire media to transmit the data from one sender to receiver. We are using a physical medium. It is called as a transmission medium. So the digital binary stream in convert to digital, it is called as a digital form. The digital form in convert to analog signals to transmit to the cable to receive the receiver end. The analog signal is converted to digital form is ones and zeros. The receive the physical medium is a ones and zeros data. In data link layer, collect a bit stream into a frame. It is called as a manageable data unit is called a frame. You add a physical address of the uh, data, and here we follow the flow control and error control, access control. So data flow between the sender to receiver is a synchronized manner to receive the same type of data. The data would be easily uh, understand the end user. Error control cannot change any error between the data. Easy to access one by one the data. This is a simple architecture for an data link layer. The network layer they receive the packets from the data link layer. In data link layer is converted to frame. Frame into convert to the physical layer ones and zeros. So receiver end receive the ones and zeros to convert to the frame into packets. Network layer deliver the only the packets of network layer, handle routing and among the node within the packet switching and network. Here implement the logical address for the data. This is a simple architecture for network layer. So here mostly we have 7 layers. The host one is a sender, host B is a receiver. So host in application layer, the data transmit to the presentation layer to encrypt the format to the session layer transmit to convert to the data segments into transport layer. Transport uses the segment to transmit the packets from the network layer. Network layer transmit the packet into frame in the data link layer. Data link frame receiver to physical is a binary format to transmit the receiver end. Same reverse process will be happen in the sender side. So encapsulation is frame in the sender side. So receiver side is decapsulate the data from the receiving side. So transport layers. So here you are using a process to process communication. So here data is processed into segments. Here added to port address for the each and every data. Here a connection control will be take place and flow and error control will be take place. Next layer is a session layer. Session layer is provide yeah, same space that used to combine different transmission stream, dialogue control and synchronized control. Here's a simple architecture for the physical application layer and presentation layer, source and destination. Application layer transmit the data from the transport and network layer. So data link layer link to the neighbor routing the tables. So we added to the, some physical address and port address to transmit the data between the nearest node. So it is a simple architecture for transport layer. So receive the segments or presentation layer. So segment is processed to say, transport layer, transmit layer to process it, then convert to the segments into packets and then next level layers. So presentation layer is concurrent about the format of data exchange between the peer to peer. Here, your syntax and semantic information will be takes place on presentation layer. So here is sender side encapsulate the data. So receiver side you decrypt the data. So on same time the data is compressed between the sender to receiver. So IMO's layer is an application layer. Here standard common to exchange the original information data into lowermost presentation layer. The represent for the following network users. So here we are using a file transfer access management protocols. So here most of the protocol HTTP, STTP protocol we are using an application layer to transmit the file into lowermost layer. This is a presentation layer diagram. So form of receive the original information to the application layer. So you encrypt data from the sender side. So transmit the next level layers, session layer. The session layer receive the data from the uh, presentation layer to decrypt the data and transmit in the application level layer. Last only is application layer. Application is a higher lower layer. So each and every layer we have a unique process from the YC model. So application layer receive the data to the end user. So user to transmit the encapsulation and segment and packets and segments packets and frame and physical layer receive the binary stream. Same process will be decapsulation between the physical layer, receive the bit stream, convert to the frame convert to the packet convert to the segment convert to the syntax and semantic convert to presentation layer is on a form of decapsulation. The application layer receive the exact original message sent to the sender. The physical layers is mainly hardware and signal mechanism. So physical layer connected to or two different sessions. The physical layer defines the hardware requirement for cable wiring and frequency etc. So physical layer provide service data link layer. The binary data sent to wire or wireless medium. So here some sort of function will be takes place in a physical layer. Physical layer represent the bit stream, uh, bit stream and bit rate, synchronize the bit, interface between sender and receiver, a line configuration. We are using more number of topologies and we are using transmission medium. The physical layer is perform some transmission process. We are maintain the bandwidth and bandwidth frequency The bandwidth transmitting sender and receiver in the bit stream. We are also calculate throughput, so a latency of delay between the sender and the receiver. So we calculate the delay is equal to progression time plus transmission time plus sequence time plus processing time. A processing time is equal to a total number of distance between sender and receiver divided by progression speed. It is known as progression time. Transmission time is a total size of the message, and we are using a bandwidth of the system. So queuing time is a waiting for the one data to the another data. So bandwidth will be delayed for the protocols. Thank you.
Good morning, one and all. Today we discuss about the data link layer and MAC. So, data link layer and MAC address we have on several topics: introduction, node and links services, and categories of link, sublayers, linking layer. So, addressing of type of address, ARP, and data link layer controls. So, services we have one of parent, flow, and error control, data link layers, simple protocols, stop and wait protocol, bit packing, layer 1 and layer 2 architectures, random access, and all called CSME, CSME slash CD, CSME and CA, and controlling access receiver, pooling, and token passing. So, introduction, node and links. The interconnection between the various communication device through the different communication link can be defined as a network. The network is used to exchange and store and send and receive the data between the network device is known as network node. So network services, the computer networks service aim to study and analyze the communication process among the various computing devices or computer systems that are linked or network together to change the information and share the resources. In network services, so implementing the network as a service can significantly reduce the IT cost, introducing the infrastructure, hardware, and software cost, as well as operational and maintenance and service cost. The data link layer is often divided into two sublayers: logical link control (LLC). So it is control the synchronize and flow control and error checking function of the data link layer. The media access control (MAC). MAC is responsible for the transmission for the data packet to send from the network to interface card and from another remotely shared channels. The link layer address. The link layer address is called as a link address is called the physical address or sometimes is MAC address. Since a link is controlled at the data link layer, the address need to be belongs to data link layers. Each computer interface, one the LAN is assigned the sequential physical address is called hardware address or media access address. It is called as MAC address. MAC address is a 6-bit byte address or 40-bit long, usually written as a hexadecimal. For example, 1A-23-CD-06-9B. This is a simple architecture for the MAC address. We have on a several number of systems. So each system we have on a unique MAC address to control the router. Data link layer protocols. The data link layer we have on a several protocols. They are SDLC, SDLC, SLIP, and PP, and LCP, and LAP, and NCP. So type of address. Every computer or device internet has been two different type of address: physical address or internet address. So physical address is called a media access address or MAC address. Internet address is identify the device to other device, the same local area networks. The types of address TCP/IP support the three classes of internet address: Class A, Class B, and Class C. The different classes of internet address are designed by the 30-bit 32-bit address are allocated. A particular address is classified network is assigned depends upon the size of the networks. The IPv4 address IPv4 address is system is divided into five classes of the IP address. All five classes identify first by the first octet is IP address. So the octet number is assigned a dotted decimal notation. The binary notation called as a 11 000 000 dot 10101000 dot 0000001 dot 1001100. The decimal notation for the previous binary notation is called 192.168.1.152. So we have on a several class. Just the first class is the class A address. The first bit is the octets is always set to be 0. Those the first octet range from a class A 1 to 127. The binary value for the first octet double zero double zero double zero 0 1 and end with 0 all 1. So 1 to 127. The IP starting from 1 dot x dot x dot x to 126 dot x dot x dot only. The range of IP 127 dot x dot x dot x is received from loopback IP address. Class A address is a difficult to subnet mask for Class A IP address is 255.0.0. The subnet mask is Class A IP address 255.0.0.0. The card address has been a 126 network 2 power 7 minus 2 and 16777214 hosts are connected to the Class A address. In Class A address, we have first octet is a network ID, the remaining three octet is a host ID. Class B address. The Class B has been the first two bits is the first octet set to 10, 1, 0. So those the first octet range one from 128 to 191. 1000000. So 128. So 191 is 10 all 1. They are starting from 188 0 dot x dot x 191 dot 255 dot x dot x is only. So class B address is difficult subnet mask from a class B. IP address is 255.255.x.x. The class B has been 16384 to power 14 network address and 65,534 host address. So 10 here class B we have on a 2 network address and 2 host address. So class C, the class C has been first 3 bits are said to be 1010. The first octet range from 192 to 223. So double one double zero double double zero double zero. So is 192. So end with double one zero triple one double two 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 three. The range starting from 192 dot 0 dot 0 dot x to 223 dot 255 dot 255 dot x only. The class D address. The class D has been the first two bits in first attack said to be 1110. The first attack range is from 224 to 239. So the range of 224, 1 triple 1 triple 0 double 0, triple 1 0 4 1. The IP starting from 224.0.0.0 to 239.255.255.255 only. The Class D address reserved by multitasking. Class D does not have any subnet mask. So Class C address, the Class C is address received from the external purpose only on until those of first attack range is 240 to 255, starting from 240.0.0.0 to 255.255.250 only. The class does not have any subnet mask. So address resolution protocol (ARP). Address resolution protocol is a protocol or procedure that contain every changes of internet protocol. So address are fixed. The physical machine address is known as media access or control. So it is a local area networks. So address resolution protocol is produced for the mapping and a dynamic IP address to permanently physical machine address in a local area network. The physical machine address is also known as media access control. It is called as the MAC address. This is a simple architecture for MAC ARP. So we have on a several number of system. Each and every system have a unique MAC address. So the router, the senders send the request from the uh, sender to the receiver to receive the data from the networks. So we have one of four types of network: proxy ARP and generic ARP, inverse ARP and reverse ARP. So ARP is used to network layer communicate with the device both in and outside the local area network. IP address is recorded uniquely with the local area network. They assign the logical and rather than physically. So the device's IP address change over the time. The ARP table is to maintain correction between the MAC address. It is corresponding to the IP address. An ARP request is sent to all devices on Ethernet LAN and contain the IP address of the destination host and its multitasking of MAC address. If host is ready to send the packet to local destination device, that it be the IP addresses, if not the MAC address of the destination, it generates the ARP broadcast. Data link control, the communication between two adjacent nodes, node to node communication. Frame can be fixed size, no need any boundary of the frames. Link level flow control, the sender waits for positive acknowledgement before the advancing to next data item is obtained, called as a positive acknowledgement. With retransmission, automatically repeat and request. The steps of ARQ: transmission from frame, error checking, and receiving error. So provide acknowledgement for the particular frames. There are two types of acknowledgement: negative if any error is detected, positive no error detected, and retransmitting the data. Frame is a manageable data unit is called a frame. Frame is a function of the data link layer. It's provide a always to sender to transmitter submit that meaningful receive receiver. The Ethernet, token ring, frame blade, and other data link technologies have their own frame structures. Flow control and error control. Flow control, it is a method used to maintain the prior transmission of the data from sender and receiver. Error control, it is used to ensure that error-free data is received the sender and receiver. Flow control. Flow control, we have only two types of flow control. So stop and wait flow control, sliding window protocols. And noisy channels protocol is called as sliding window protocol and stop and wait ARQ protocols. Sliding window protocol. Sliding window protocol is a data link control protocol to receive the sequential delivery of the protocol. The sliding window is also used to transmit the control protocol. The protocol's multiple frame can be sent by the sender and time before receive an acknowledgement from the receiver. So this is a simple architecture for the sliding window protocols. We have on the two station. So station one transmits the data from data sender to station two. So first establish the connection and then send the data. So acknowledgement received to transmit the data to the sender to receiver. Stop and wait ARQ. Stop and wait ARQ is a data link protocol to transmit the frame over the noiseless channels. It's provide directional data transmission with the flow control facilities without any error control facility. So this protocol is taken into account of that receive the witness process of speed. This is the sender and receiver. So we can transmit the data from to enable the receiver to transmit the data simultaneously. So next noisy channel. If you are on two types of noisy channel, go back and ARQ, selective repeat and ARQ. And go back and ARQ, go back and automatically repeat across go back and ARQ is a data link protocol that uses a sliding window method for replace and sequential delivery of the frames. And also class of sliding window protocol to send windows size of n and receive the window sizes 1. In case of if a sender does not receive any acknowledgement, then enter the Windows frame. It will be transmitted in that use case. The go back and ARQ protocol lead to the transmission of the last frame after the enterprise in the timeout timer. So, for example, to sender and receiver to transmit the data, in case of any lot of loss of the data, you retransmitting particular data to remaining data. So selective and repeat ARQ. The selective and repeat protocol also called selective repeat ARQ automatically repeat and request. Is data link layer protocol that use sliding window method use replay delivery on the data frames. So only the errorless and loss of the frame is transmitting while well and good frame are receiving and buffers. This is a selective and repeat concept. The sender receive the data. To in case of packet is 2 is lost means to retransmit all the packet from the selective and repeat. So in selective repeat to loss of only a packet but transmit the data. So picky banking. Picky banking is sometimes is referred to as a Wi-Fi square routing. So usually for process of picky banking is simple to gain the free network access rather than any molecules input. So but they will slow down the data transmission, lagging time user of the networks. The piggy banking is a method for attaching the acknowledgement to outgoing data packets. The concept of piggy banking is explained as the following. Consider the two way of transmission between the host A and B. When host A sends the data from B, then B does not send acknowledgement of the send frame the sending immediately. Example host A and host B. So data sent to A host A to host B. Send the data. The B is receives data. So same time to add the data to the acknowledgement from the host A. Each and every time draw on transmission for the picky pancake. Random access. In random access, one or more station cannot be depends upon another station. Any station control any other station. Depending on the channel state is ideal or busy, each station transmitting the data frame. However, if more than one station send the data overall channel, there is maybe collision or data conflict. Example, we have on several station 1, station 2, station 3, station 4. Each station you can transmit at a time transmit the data from same network. You can happen the solution will be happen. So this avoid this collision. You can transmit each and every station in new sequential form. Next, ALOHA. So ALOHA is a multiple access protocol from transmission data via shared network channel. This operates the medium access control of sublayers. So a open system so interconnection of OSI model. Mm, uh, ALOHA Random Access Protocol. It is designed by wireless and local area networks. So, but can also use to share the medium and transmission data. These methods in any station can be transmit the data across the network simultaneously when a data frame set is available from the transmission. The types of ALOH is a pure ALHO slotted ALOH. The pure ALHO used to data is available from sending an over channel station. A pure, however, when each station transmits the data to channel without checking whether the channel is ideal or not. To change any collision may be occur in the data frame can be lost. So this is simple architecture for the data transmission. Here we have several frames will happen in a collision. So each and every frame we transmit in from the reduce the collisions. So pure alcohol efficiency, maximum efficiency of pure alcohol is equal to 18.4%. The maximum efficiency of alcohol very less to large number of collision. So slaughter alcohol is introduced in 1972. Robert, this improved the overall pure alcohol. The time division is described interval is called slot, corresponding of the frames, working the principles. So the communicating station agrees upon the slotted boundaries. The station sent to the frame each slats. So time divided into equal size of slot equal to packet transmission time. The node with the new packet transmit the beginning of the next slot. If collision is a retransmission, the further slot will be probability of queue until success. The slotted algorithm is used to low data rate satellite communication network. So multi-purpose and subscribe based on satellite communication network and mobility telecommunication network. Set-top box communication are using the slotted outcome. RFID technology. RFID technology are used to type tracking the system that use the reduced frequency to search and identify and tracking and communication with time for people. Establish RFID has a small label that can be store the range of information from several number of shorter description and even the page of data. This is a simple architecture for RFID. You can track the uh, identification, tracking the devices and radio wave communication and technology, and also use information technology also. So RFID technology automatical data collection and basically reduce the human effort and error. So you support the tag reading while no line of sight of the item by item scan at out. RFID reading and read a multiple RFID tag simultaneously offer increase in efficiency. Next is carrier sense multiple access CSME. The algorithm CSME is when a frame is ready to transmit a station, check whether the channel is ideal or busy. If the channel is busy, the station waiting until the channel become ideal. If the channel is ideal, station will start the transmission continuously monitoring the channel and detect any collision will be occur. This is a simple architecture for carriers in multiple access. We have on a four nodes A, B, C, D. So transmitting the data from node A to D. Here you transmit the data to the B sensing here, C also sensing, and finally D is receiving the data. So time will be calculated vulnerable time equal to progression time. So both are same, the transmission without any error loss. So carrier sends multiple access. Multiple access carriers with multiple access with pollution detection help the host to decide when the sending packet and share the network segment and how to detect the pollution if any occur. For example, the half network, two devices can be packets in the same time that can be occur in pollution. In this diagram, we have on a four host A, B, C, and D. The host, the same time, the host A and B is connected to the hub. Both are transmitting at the same time. The collision will be occur in the uh, hub. Thank you.
அப்படியா?